Okay, let's take a look at this optimization problem. So pause the video and read the question. Okay, I am trying to maximize revenue. So I may have to do, you may not realize how to find revenue from a cost function, but revenue is always price times quantity. And we call this, I shouldn't have said a cost function, we call this a demand function. It's the number you're going to sell at a particular price. So this guy here is called a demand function or a quantity function. So R as a function of price is always P times N of P. That's price times quantity. So in this case, that'll be P times 1,000 minus 5P. So revenue is how much money you bring in. So imagine you're selling lemonade and you sell 200 cups of lemonade at $1 each. You've made yourself $200. Price times quantity. We're just letting price be our independent variable here. Okay, so if we clean that up, that would be 1,000 P minus 5P squared. And I want the goal here. Well, let's write our domain first. So domain is 50 to 200. We are told that if they charge $50 or less, they're going to run out of cars. You know, you can make more money if you still had a couple cars left. They've run out of cars. They're too cheap. They're not making enough money there. If they charge 200, nobody buys any. Like you could see that, plug in 200 there, you get number rented is 0. So these are our bounds. This is our domain of interest. We want to maximize revenue. Okay, now from a calculus standpoint, we have a function. We have it written in terms of a single variable. We want to maximize or minimize it. We're going to take the derivative, set it equal to 0. Find all our critical points. From a college algebra standpoint, well, we already know the answer. It's a parabola. Right? It's a parabola. Look at this guy. And in fact, if you plug in 0, you're going to get 0. If you plug in 200, you're going to get 0. Revenue is going to look something like this. Now, we only care about this region of interest from 50 to 200. But the point I'm making is we already know how to maximize a quadratic. It's the vertex. Negative b over 2a. Plug it back in, you're done. Like this is the college algebra problem. So I'm not even going to bother checking the endpoints and all that. I know the maximum occurs at the vertex. And again, if you already know college algebra, you know where that's going to occur. It's going to be halfway between the roots. Okay, but let's do it. Let's do it using calculus. R prime of P will be 1,000 minus 10P. I set that equal to 0. We get P equals $100. Profit is maximized at $100. And again, I don't have to check the endpoints. I don't even have to check them because I know what the graph looks like, because I know this is a quadratic and the maximum value of an upside down quadratic is going to occur at the vertex, and that vertex is in my interval. So they should charge $100. And the max revenue, the actual value of it, is whatever we get when we plug that back in. R of 100. So I'm not gonna. I mean, we can just do this in our calculator here. So 1,000 times 100. Minus 5 times 100 squared. 50,000. And then this is what we would circle. There's our final answer. Remember, word problems have word answers with units. And that's a good place to stop on that one.